Okay, so now that I'm recording, please don't forget one of our last major grades will be the test next week. Okay, it's going to be a short week, so I'm only going to be able to see you Tuesday and Wednesday before we take it. So if you do have any questions, please come on in. You know, talk about whatever difficulties you may be having. Now, we've been talking about the unit circle lately. We've been talking about the patterns in order to create it. Now, I will not be providing a unit circle for you on the exam, but I'm still going to have you evaluate trig functions. Okay, so if you get to the point where you can recreate the unit circle, I would say in 4 minutes, definitely not more than 5. Maybe that's what you want to go ahead and do for the exam. Okay, if anybody feels comfortable doing that. Anything longer, you're taking up too much time and you probably won't be able to finish the test. So the way I've been showing you how to evaluate the trig functions is to first identify what quadrant, where that terminal side is going to be, and then using that terminal side and the reference angle, we create a right triangle that we can then evaluate. Okay, that's the two parts to it. All right, now speaking of, let's go ahead and take a look at this very quickly. We're making a push away from the opposite, adjacent, and hypotenuse. We want to look at these trig functions now in terms of the radius, the horizontal distance x, and the vertical distance y. Okay, so Ethan, what ratio is sine? Oh, no, that's tangent. It's y over radius. There we go. So y over r. Let's see, cosine. Kyle, help me out with that one. Okay. Raphael, help him out. X over r, yes. Okay. And we already heard tangent just a second ago. That's going to be y over x. And now their reciprocals are just going to follow the same suit. You're just going to flip them. The reciprocal of sine being cosecant, which will give you r over y. Then secant would be the radius over x. And finally, cotangent would be x over y. Okay. Now, if we are on the unit circle, what's that value of r going to be? It's just 1. There we go. Now, we are going to go ahead and start looking at some problems today where we won't be on the unit circle. But those special right triangles we've been talking about, they're still going to apply. Okay, and as far as points on a circle goes, you know, we're looking at them in terms of cosine of theta, that's your x value. Sine of theta will be your y value. Okay, now if you are on a circle that's not the unit circle, you're just going to go ahead and say the radius times cosine, the radius times sine, and that'll give you the point that you're looking for. Okay, but let's go ahead and take a look. How far did we get? I know we got the tangent one done, right? Did we get the secant one? So we did get secant done. Okay, so let's go ahead and take a look at cosine of 4 pi over 3. Did we get that one? No, okay, let's do that one. Okay, so the cosine of 4 pi over 3. The first step, we got to figure out what quadrant, excuse me, that angle is going to put my terminal side. Kimberly, can you help me out with that? 4 pi over 3. Where would that put the terminal side? I'm sorry? Third, absolutely right. Because we have 0 radians. This is pi over 2. We have pi, 3 pi over 2, and then 2 pi. Okay, so if I were to just rotate halfway, that's pi. And, you know, if it really helps, rewrite that as a mixed number. 4/3 is 1 1/3 pi. So see, half that revolution, there's the 1. And now all I want to do is rotate an additional pi over 3. So I'm going to end up right here. Okay. Now I'm going to go ahead and use that to create a right triangle. Okay. But it's the reference angle that I'm really interested in. Okay. How much further than pi did we rotate? 1/3 pi, right? So we rotated an additional pi over 3 radians. But what's pi over 3 in degrees? That's 60. Okay. So I know this is 60 degrees. This one has to be 30 degrees. And it's that same 30, 60, 90 that we see in the unit circle. I know that his radius is 1. What is always across from 30? 1/2. And across from 60, square root of 3 over 2, right? But there's something I seem to be forgetting. There you go. We're in the third quadrant. This is where both x and y are going to be negative. So negative, negative. And if it helps, go ahead and label those sides. This is my radius. This is the x value. This is the y value. Okay. Well, that is pretty much the work right there. Once you go ahead and find where the terminal side's got to be, you use him and the reference angle to create a triangle. You no longer need him. Now, using what you created, what does cosine want? Cosine is just what? He is just the x. So what's the x value from your picture? There you go. So the cosine, bless you, of 4 pi over 3 is just negative 1/2. That's it. What if I were to ask you for sine of the exact same measure? If I want sine of 4 pi over 3. Well, that would just be negative. That's a 3. Square root of 3 over 2. That's it. Okay. Now, what if I got a little tricky? What if I said I want the cotangent of the 4 pi over 3? Now, we already know what the picture looks like. We know exactly where we're at. What is cotangent's ratio? It's x over y. Okay. So I'm going to take the x value from my diagram, negative 1/2. I'm going to divide it by the y value, negative square root of 3 over 2. And then I would just use some algebra to go ahead and simplify that. Okay, that's all we have to do to evaluate a trig function. Remember, here in the beginning, we are only going to be looking at these 16 values, those 16 points. Or I should say points that are coterminal with those. So every time we stop on one of the points, you should get a reference angle that's either going to be a 30, 60, 90 or a 45, 45, 90. Okay. Does anybody want me to go ahead and finish this up? Okay. Enzo, you want me to do it? Let's do it. All right. So how would I simplify this? If I'm dividing by a fraction, okay, so this would be negative 1/2 times negative 2 over the square root of 3. So let's say two negatives are definitely going to give me a positive. Those 2's are going to cancel. So it looks like I have 1 over the square root of 3. And then we would have to rationalize. So square root of 3 over 3. There you go. That would be cotangent of 4 pi over 3. And couldn't I easily find the other trig functions as well? This is eventually what your happy minutes is going to become. I'm going to go ahead and give you either a radian or a degree measure, and then go ahead and say, okay, find me the 6 trig ratios. So we're going to start off probably with 4 minutes, 4 or 5 minutes. Then the next week will be 1 less. Then the next week will be 1 less. So we're going to practice, and you're going to get good, and it's going to be frustrating from time to time. That's okay. Okay, we will get better. Dylan. I'll do it on the unit circle. Or, maybe I could kind of shake things up a bit and give you something else. Because, Dylan, you look like you're smiling when I say that. You look pretty happy when I said that. There you go. But then again, you always look pretty happy. There you go. Okay. So let's go ahead and start taking a look at some other kind of problems, and then we'll get back to just practicing some evaluating. Use one trig function to find others. Okay, so I have no idea what theta is here. We're not trying to find theta. We know that secant of theta is equal to the square root of 29 over 5. And we know that the sine of theta is greater than 0. Well, if we're greater than 0, that means we're positive, right? Okay. The thing is, this triangle could be in any of the 4 quadrants. That's why we have to look at the sine of both to help me decide which. What I like to do is draw my little diagram like I do here, the x and the y axes, and I go ahead and put a check mark for each of the trig functions that I have. Let me show you what I mean. Let's start with sine. We said that sine was positive, right? What was that little phrase I said the other day? All students take calculus. So all students take calculus. So I know that all 6 trig functions are positive here. Sine is positive here, tangent, and cosine, right? So would everybody agree that sine is going to be positive in 1 and 2? Yeah. So see, I'm going to put a little check mark in those quadrants to let me know that satisfies that condition. Okay. Now, I'm going to go ahead and do the same thing for secant. Is that a positive or a negative ratio? That's a positive, right? So in what 2 quadrants will secant be positive? Now remember, he's the reciprocal of what? Cosine. So he's going to be positive wherever cosine is positive. So that's what 2 quadrants? That would be 1 and 4. So you see how I'm looking at the quadrants based on their signs? Well, how does this help me? How do I know what quadrant to use now? Use the quadrant where they overlap that has the most check marks. So I know that this triangle has to be in quadrant. Whatever theta is, it's less than 90. Okay? So I'm going to use him to create a right triangle. So theta is once again going to be my reference angle. And we have no idea what theta is, and that's fine. Okay? So now, do we know the side lengths of the triangle? Yes. We actually do. What is secant's ratio? Remember, secant is r over x, right? So see, the 2 parts of the fraction are the sides of my triangle. I know the radius is the square root of 29, and I know the x value has to be 5. Everybody see how I did that? Okay. Now, we are missing something. I do need to find the y value, and how can I do that? Pythagorean theorem. Okay, so we're looking for y. So the square root of 29 squared would equal 5 squared plus y squared. And what would that be if I were to solve it? 2. So I know this is 2. There we go. So is everybody okay with how I used the signs to determine the quadrant, and then I used that value to create the triangle? I mean, this could be a special right triangle. We don't know. We don't have any idea what theta is. Probably not, based on the side lengths. Okay. But now we just want to go ahead and find the other 5. So this is just like you did on your happy minutes. Okay, you now have a triangle with all 3 sides. We just want the ratios. What would sine of theta be? Let's say, remember, that's y over r, right? So I heard 2 over square root of 29. But we can rationalize that pretty quickly. Square root of 29, square root of 29. So it looks like 2 square root of 29 over 29. Okay. And now let's move on to the next one. I want cosine. Now, what's cosine's ratio? It's x over what? X over r, yes. So this time I'm going to say 5 over the square root of 29. So what would that be if I rationalized it? So 5 square root of 29 over 29. And take a look. Remember, we were given secant, right? What I first wrote for cosine, well, wasn't that just the reciprocal of what secant was? Yeah. Okay. Now let's do tangent. Tangent's what? Okay, it's always y over the x, so 2/5. Now let's go ahead and get cosecant. Now if you want, you can go ahead and take the answer for sine and just flip it and rationalize. It's going to give you what you want, but in a case like this, I would probably just go back to the diagram. Remember, sine is y over r, so cosecant has to be, there you go, r over y. And see, if you went back to the diagram, it just saves you that time. You don't have to worry about rationalizing. Okay. Now, we already have secant. We don't have to worry about him. What would cotangent be? 5 over 2. I just take the reciprocal. There you go. Anybody having a hard time? Okay. Any questions? No one thinks I'm trying to trig them. A little bit of a push, but I'm going to stand by it. Okay. All right, let's try another one of these. So I'm given that cosecant is -3, so we can obviously tell that is a negative value. And what are we told about tangent? Less than 0, so that means he's negative as well, right? Okay. So take a few, well, maybe take a minute or so. Go ahead and try to determine what quadrant this triangle is going to be in. And then if you're feeling really ambitious, go ahead and write out what the side lengths of that triangle is going to be. While you guys are doing that, I'm going to go ahead and pass out this. This is your assignment. Okay, now this is not going to be due until Wednesday. Okay. But I might go ahead, whoops, sorry, Jacob, take at least a couple minutes this weekend, look over it, make sure that you feel comfortable with this. We're going to wrap this lesson up on Tuesday, and then we should have some time in class to work on it as well. Yes, there you go. I was just about to say that. You'll notice there are 60 problems on here, but you only have to work the circled ones. Okay. But this one's also kind of unique because, Satish asked about this just a little while ago. If you feel you want some extra practice, you got a ton of extra practice on this. Okay. Now, also, if you guys could help me out, does anybody know anybody in this class who's at Mamma Mia right now who they'll see later in the day? If you want to go ahead and take a copy of the assignment to them, that'd be great. Or if you could just kind of pass along the word, that we passed out homework today. Okay. Or go to the web, however we want to go ahead and do it, website or come see me. Okay. So let's see here. First off, what was that phrase? All what? All students take calculus. So maybe it's easier for people to go ahead and think about where these functions would be positive, and then we'd know where they'd be negative. See, for example, tangent is going to be positive in 1 and 3, right? So that means he's got to be negative in 2 and 4. So I'm going to put a check mark there for each of those. That takes care of him. Now, in what 2 quadrants would cosecant be negative? 3 and 4. So I'm going to put a check mark here, check mark here. So what quadrant am I going to be working in? It's got to be the 4th quadrant. Okay. So how many people got the 4th quadrant? Okay, so that's not bad. Not bad. Let's go ahead. Here's my terminal side right here. I'm going to use him to create a right triangle. Now we're still on the unit circle, so I know that the radius is going to be 1. But this one's a little different than the previous one. See, secant gave me a fractional value, so I was able to see this right off. What is cosecant's ratio? It's r over y, right? So what do I do here? There you go. If it's not a fraction, make it a fraction. Just put it over 1. Okay. Now, here's the thing. Oh, and actually, yeah. Sorry, we are not on the unit circle like the previous one. We're just saying if you're paying attention, obviously you were. Okay. But I was just thinking about this. Where would the negative have to go? With the 3 or the 1? Has to go with the 1. Our radius is never going to be negative. Okay. So if you do have a negative ratio, it has to be one of those side lengths, not the radius. Sorry about that. Okay. And the previous one, we are not on the unit circle either. We had a radius of the square root of 29, which is much larger than 1. But was everything still the same? Yeah, nothing changed, right? Okay. So has anybody figured out what my x is? What is it? Okay, so it is the square root of 8, but let's simplify that. 2 square roots of 2. So the one thing, if it's not a perfect square, we definitely don't want to go decimal, but we do want to simplify it if possible. Okay, and then theta Again, we have no idea what theta's measure is, and that's fine, but he's my reference angle. Does anybody want me to walk through how I got 2 square root of 2? Everybody okay with that? And then from here, again, use the triangle. Go ahead and find all those trig functions. Like, let's start with sine. Okay. Excuse me. So sine, remember, is y over r. So what would that be? Negative 1 over 3. And that makes sense because the reciprocal of negative 3 is a negative 1/3. Okay. And then you would just continue. So I'm not going to worry about finding the rest of those. I'm confident that you guys can do that. And we're going to continue to practice. But let's go ahead and look at another problem. Okay. It says a student programmed a 10-inch long robotic arm to pick up an object at point C and rotate through an angle of 150 degrees in order to release it into a container at point D. Okay, so let's say this pivot point right here in the middle, that's my origin. So we're still putting this circular, the circular pattern that this robotic arm is going to revolve through on your coordinate system. So what are the coordinates of the ball where it starts? 10, 0. Okay. And here's what the question is asking. Once it rotates this 150 degrees and it goes ahead and drops the tennis ball, we want to know what are those coordinates where it drops it. Okay. So let's take a look. And we're going to use the reference angle just like we have been in the other examples. Now you'll notice this robotic arm, well, he's going to be your terminal side. He's the actual part that's rotating, right? So let me go ahead and draw this a little bigger over here. All right. We know we rotated 150 degrees. So what would this reference angle be? 30. So I know this would be 60. This would be 90. But how do I know I'm not on the unit circle? The radius, the length of the arm is 10, what are we talking about here? Inches. Okay, now that means that I can't go ahead and use the 1/2 and the square root of 3 over 2 like we have been with the unit circle, but that's still okay. We just need to know the relationship between the sides. Remember, whatever's across from 30, that's always x. Okay, whatever's across from 60 is always x times the square root of 3. And then the hypotenuse is always double what the shorter leg is. So can anybody tell me what's the value of x? It's got to be 5. Okay, so this value of y right here has to be 5. What's my x? 5 square root of 3, but we are missing something. Remember, this right here was the origin. So negative. You can always think about what quadrant you're in. So if this point right here represents where the arm is going to drop that ball, well, what would the coordinates be? Okay, negative 5 square root of 3, and then 5. Because in order to go from the origin to this point, you had to go left that distance and then up. Yeah. Is everybody seeing how this works? Is anybody having any trouble? Okay. Well, let's look at this one right here. We're talking about a big clock, analog clock. All right. A 4-foot-long minute hand on a clock bell tower shows a time of 15 minutes past the hour. What is the new position of the end of the minute hand relative to the pivot point, that point at the end of the minute hand, 5 minutes before the next hour? Okay. So somehow I need to create a triangle to help me with this. Do you guys want to try this one on your own? Okay. Now, if you're talking, just in terms of the problem, okay, right here, the tip of the minute hand is starting at 40. Because remember, the length of the minute hand is 4 feet, right? So time passes. We want to know the coordinates of that tip 5 minutes before the next hour. That's what we're trying to find. Okay. Excuse me. Oh man, it's already 10:48, so we're almost done. Time flies when you're having fun. And if you actually want to see time fly, you just throw a clock out the window. What's that, Raphael? That would be impressive if you're going to throw a clock that big. I'd have to hand it to you. Hand him a clock. Yeah. I think it's about time we did something like that. I stand by it. Okay, well, since we are running out of time, this is the triangle that we'd be interested in, right? So let me see if I can recreate it here. So this would be the very center of the clock. This would be 0, 0. This is the point that we're looking for. Okay. Well, this segment that I have going up right here, if I knew this angle, well, then I could find that reference angle for the triangle. So how many 5-minute increments do we have in a clock? There you go. They're 12, right? So they're evenly spaced, so this would have to be 30 degrees. So let me go ahead and take this out right here. So this would be 30 degrees. That means the reference angle would be 60. So this one's 30. So again, this one, I can't say 1/2. I can't say square root of 3 over 2. We're not on the unit circle. The length of that minute hand is 4 feet. So what's across from 30? Okay, and you put the negative on there. Very good. Remember that the shorter leg is always half the hypotenuse. But the negative is on there because we're in the second quadrant. So what's the height? Oh, but we're not going to take the decimal. So it would be 2 square root of 3, right? Okay, so that should be the coordinates right there. In order to go from the origin, the center of the clock, to that point we're looking for, you'd have to go -2, 2 square root of 3. Now, think in real terms. We're not saying that that's -2 feet. We're just saying that you would have to go 2 feet left and then 2 square root of 3 feet up. Does that make sense? Okay. How we doing? Now, the one thing I'm worried about more than anything is being able to evaluate trig functions. Are we at least starting to feel maybe a little more comfortable finding the reference angle, creating the triangle, and going from there? Okay, we're going to practice it, so don't worry. All right, so that bell actually should be ringing pretty quick. Okay.